Okay, so the second part of this unit was about systems of linear equations. So we have to be able to know if a point is a solution to the system. And remember that a solution to the system has to make both equations true. So if I'm given a system of equations and a point, I substitute this for x and this for y. And I've given 2 here, so I'm going to have to do it actually 4 times. I'm going to have to check this point in both equations, and I'm going to have to check this point in both equations. Okay, so for part A, I want to know if 2 times 6 plus 3 times negative 1 equals 9. Well, this is 12 minus 3 is equal to 9, so that one's true. Then I want to know if negative 5 times 6 minus 3 times negative 1 is equal to 0. Well, negative 30 minus 3 equals 0 is false. So the answer here is no. I'll do the same thing with part B, but here x is negative 3 and y is 5. So I want to know if 2 times negative 3 plus 3 times 5 is equal to 9. So that gives me negative 6 plus 15 is equal to 9. That's true. Then trying the other equation. So I want to know if negative 5 times negative 3 minus 3 times negative 5, positive 5, is equal to 0. So this gives me 15 minus 15 is equal to 0. This is also true, so this is yes. Okay. 47, the same thing. We're just going to look at 2 different equations. All right, so for part A, this is x and this is y. So I want to know if 3 times 2 plus 1 is equal to negative 7. So 6 plus 1 is equal to negative 7. No. This is false. So I don't even need to go any further. Okay. So let's look at part B, negative 2 and negative 1. So 2 times negative 2 plus, I did this equation first. 3 times negative 1, is that equal to 7? So negative 4 plus negative 3 is equal to 7? No. So the answer here is no and no. Once you find that one equation is false, then it's not part of the system. Or not a solution to the system, excuse me. Okay, solve each equation by graphing. That means we're going to graph both lines, and from there we are going to try to find the point of intersection if in fact there is one. Now, for this equation here, there are a couple of ways that I can do it. But for this equation, I would like to put it in slope-intercept form, which means I solve for y. So I'm going to subtract x from both sides, which tells me that y is equal to negative x minus 1. So my slope is negative 1 over 1, and my y-intercept is 0, negative 1. So I start at 0, negative 1. This tells me to go down 1 and to the right 1. Down 1, right 1, down 1, right 1. And again, I'm going to do it several times because I really want this to be an accurate graph. And I've got to find where these points intersect. All right, this one here is already in slope-intercept form. So my slope is 2 over 1, and my y-intercept is 0, negative 7. So I start at 0, negative 7. This tells me to go up 2 and over 1. So up 2 over 1, up 2 over 1, up, and I've already found my point of intersection, but I still want to graph the line. So my solution is the point 2, negative 3. Okay, the next one. I'm going to graph this one first because it's easier. I know I start at 0, negative 5. My slope is 2 over 1, and my y-intercept is 0, negative 5. So I go up 2 and over 1. So up 2 over 1, up 2 over 1, up 2 over 1. And I connect my dots. Okay, now my other one, I'm going to do a little work on that because I've got a y-intercept of 10, but that's down here and then I have to subtract. So I think I'm going to just find some points. So for this equation, I'm going to pick some values for x, and then I'm going to find out what negative 3x plus 10 is. Okay, so I know it's going to go way down over here, so I'm going to pick some values to the left. So let's pick negative 5. I'm sorry. 10, and it goes down this way. So let's pick 2. So negative 3 times 2 plus 10 gives me 4. So I've got the point 2, 4. Let's try 4. Negative 3 times 4 plus 10 will give me negative 2, so I have the point 4, negative 2. And let's see if that's enough points to get a nice clear picture. Oh, and I've missed, this point is 2. 2, 4. That's why it didn't work. Okay, and this is why accurate graphing is so important. This gives me the point 2, 4, and this gives me the point 4, negative 2. So now I can find that my solution is the point 3, 1. Okay, if I have y equals negative 3x minus 1, I know I begin at negative 1. I use my slope to go down 1, 2, 3, and over 1, 1, 2, 3, over 1, and I draw my line the best that I possibly can. This equation I'm going to put in slope-intercept form. So I have negative 6x minus 2y is equal to negative 2. add 6x to both sides, divide everything by -2, and I get y is equal to -3x plus 1. Okay, so to graph this one, I'm going to start at 1 on my y-axis and go down 1, 2, 3 over 1, 1, 2, 3 over 1, 1, 2, 3, 1, 2, 3 over 1, 1, 2, 3, 1, 2, 3. Okay. So if I graph this, it looks like they're parallel, which means there would be no solution. So I'm going to look at the slopes. The slope is -3 for this one, and the slope is -3 here. Same slope, different y-intercept means they are parallel lines, and there is no point of intersection, so there is no solution. Or we can use the symbol. Used way too much space there. Okay, so if we solve by graphing, we look for the point of intersection. And recall, if the lines are parallel, if the equations have the same slope but different y-intercepts, then there is no solution. If you get done fiddling with the equation and they end up to be the same line, then there are infinite solutions. All right, now let's solve some using substitution. I hope I've given myself enough room here. If not, I'll get some extra paper. Substitution means I'm going to take an equivalent of one variable that's by itself and replace that variable in the other equation with its equivalent statement. So here I know that y is equal to -3x minus 5, so I can plug that in here. So I'm going to have 5x plus 3 instead of y. I'm going to put in -3x minus 5 equals 1. And now I solve this for x. So I have 5x when I distribute minus 9x minus 15 is equal to 1. So -4x minus 15 is 1. I add 15 to both sides, and I'll continue this up here, and I get -4x is equal to 16. When I divide by -4, I get that x is -4. Okay, so now I'm going to take this value and plug it into one of the equations. So I'm going to choose y is equal to -3x minus 5. And I will take the value of x that we just found and put it in here for x. So y is equal to -3 times -4 minus 5. So that gives us 12 minus 5, which tells us that y is 7. And if you're asked to write it as an ordered pair, it would be -4, 7. Okay, so our next problem is the same. We're going to use substitution. And I know that y is the same as negative 2x minus 2. So I can switch them out. So this gives me negative 3x minus 2 times negative 2x minus 2 is equal to negative 2. So I will distribute, remembering to distribute the negative sign. This gives me negative 3x plus 4x plus 4 is equal to negative 2. When I combine these, I get x plus 4 is equal to negative 2. And I get that x is equal to negative 6. So now I'm going to take this and plug it into the equation y equals negative 2x minus 2. So y is equal to negative 2 times negative 6 minus 2. So this is 12 minus 2, which tells us that y is 10. As an ordered pair, that would be negative 6, 10. Oops. Okay, this one is not set up for substitution, but it's asking us to. But it's real easy to do. I just need to have one variable by itself. So I'm going to take this equation, x plus 3y is equal to 0, and I'm going to get the x by itself. So if I add 3y to both sides, I get that x is equal, I'm sorry, I have to subtract that, excuse me. I get x is negative 3y. So I can now take this value, since I know what x is, and I can put it in here for x. So that's going to give me negative 2. Instead of x, I'm going to put its equivalent of negative 3y plus 4y is equal to 30. That gives me 6y plus 4y is 30. y is 30. And I get that y is 3. Okay, so I'm going to take this and I'm going to put it into my equation. I'm going to start with x plus 3y is equal to 0. It doesn't matter which one you put in there. So this will be x plus 3 times 3 is equal to 0. And when I subtract 9 from both sides, I get x is negative 9. So if I want to write those as an ordered pair, even though I solved for x second, it goes first in the ordered pair, so that's negative 9, 3. Okay, good place to quit. Go to my next video.